Good day, viewers. Welcome to this class. And today we'll be looking at GC physics past questions. Let's dive right into it. Question number 1 says, state 2. Question number 1A, state 2, Roman figure 1. Advantages of nuclear fusion over nuclear fission. So we talked about the fact that what nuclear fusion is what combining together of what smaller molecules to find what form larger molecules. So what are the advantages of fusion over fission? Now the first advantage of fusion over fission is that it forms far less radioactive material or waste that are what less long-lived. What do I mean? It means that the waste from fusion is less radioactive and it does not what stay as long on the earth, unlike what fission. So the radioactive waste does not live long compared to what that of what fission. So second word advantage of fusion over fission is that what there is abundance of fuel, and the fuel is what readily available. For example, deuterium, which is easily gotten from water. So the fuel is readily available and it is what abundant. Then Roman figure 2 says, what are the methods of detection of radioactivity? The method of detecting radioactivity. One of the methods that you can use to detect radioactivity is using the Geiger-Muller's counter. So if you can use the Geiger-Muller's counter, you can also use the scintillation counter. You can also use the ionization counter. So all of these are what machines or forms or apparatus that we use for detecting radioactivity. Moving on to question number 1B, it says an electron of mass. So we have the mass of the electron. Mass of the electron was given as 9.1 times 10 raised to the power minus 31 kilogram. Moves with a speed of, so we have the velocity of the electron as 4.8 times 10 raised to the power 8 meter per second. Then said in a vacuum. The question said calculate the wavelength. So we are looking for the wavelength we do not know of the associated wave. Given that Hessenberg constant H here is, that's 6 points. So this is Planck's constant, 6.6 times 10 raised to the power minus 34 joules seconds. So we have been given this, and we know that the formula for calculating this, according to Broglie's equation, is said that what lambda, which is the wavelength, is equal to Planck's constant over mv. So this is the same thing as saying that the wavelength is equal to 6.6 times 10 raised to the power minus 34 divided by 9.1 times 10 raised to the power minus 31 times the velocity was given as 4.8 times 10 raised to the power 8. So this will give me 6.6 times 10 raised to the power minus 34 divided by 9.1 times 4.8 times 10 raised to the power minus 31 plus 8. So that will give me 6.6 times 10 raised to the power minus 34 divided by 9.1 times 4.8. So that will give me 43.68 times 10 raised to the power minus 23. So this is the same thing as saying I have 6.6 divided by 43.68 times 10 raised to the power minus 34 minus 23. So I have 6.6. So this will give me 0.15 times 10 raised to the power minus 11. This is the same thing as saying that I have 1.5 times 10 raised to the power minus 12. meters. So it means that the wavelength of this wave is going to be 1.5 times 10 raised to the power minus 12 meters. But please note that the velocity of this wave that was given in this question is a lot higher than the speed of light. So if you compare to the speed of light, it means that this particular scenario cannot happen under normal circumstances, because the speed of light is 3 times 10 raised to the power 8 meter per second. If you compare it with my 4.8 times 10 raised to the power 8 meter per second, then it means that this particular scenario cannot happen under normal circumstances, as the velocity is higher than the speed of light in a vacuum. So that is also question number 2, which says define magnetic flux. Now, magnetic flux is the product of the magnetic field density and the perpendicular area of a magnetic field. So what is that saying? It's saying that magnetic flux is the product of the magnetic field density, which is B, or you can say magnetic field strength, and the perpendicular area cos of the angle present in the magnetic field. And it can also be the measure of the amount of the magnetic field present in that particular surface or passing through the surface. So it is what the measure of the amount of magnetic field passing through the surface. So moving on to the next question, question number 2B, it says sketch a diagram to illustrate the magnetic lines of force for a bar magnet placed in a uniform earth magnetic field with its north pole pointing north, indicate the neutral point. So if I have a bar magnet, this is north and this is south. This is my magnetic north here. So these are magnetic forces, magnetic lines of force. So this is my magnetic north. So this is a bar magnet, and it is what relating with the Earth's gravitational what pull. So in this relationship, you discover that what your bar magnet here, the force of attraction or the magnetic field moves from the north down to the south. So your magnetic force or your lines of force from this particular bar magnet moves from what? The north pole of this magnet down to the south pole of the magnet. And you discover that the point where they have your neutral point, this point where you have your neutral point here indicates the point where your Earth's magnetic field coincides with the perpendicular form of your magnet. It coincides with the perpendicular symmetry of the magnet. So if you get the perpendicular symmetry of the magnet, the point where your magnetic field coincide with your what? Perpendicular what? Symmetry of this particular bar magnet is the point where we have what? Our neutral point. So moving on to the next question, question number 2C. It says, state two ways in which the Earth's magnetic field is important to life on the Earth's surface. One of the ways in which the Earth's magnetic field is important to life on the Earth's surface is one, it shields the Earth from forces or negative forces that are being carried about by planetary bodies. So the first thing that the Earth magnetic field does is to shield the Earth from what? Forces. Then the second thing that it does, it aids navigation or enables navigation. So on the Earth's surface, there's what we call what? The magnetic north. So when you hold a compass, you discover that what? The magnetic north automatically what? Adjusts based on the what? Earth's magnetic field. And that helps what? In navigation. So moving on to the next question, number 2D. It says, list two applications of electromagnet. One of the applications of electromagnet is in electric bells. In electric bells and doors also, they use what? Electromagnet. Another application of electromagnet is in MRI machines. In your MRI machines, what they use there is what? Electromagnet. In fact, even in your cranes for lifting what? Heavy metals, what they use is what? Electromagnet. That takes us to question number 2E, which says, in a certain house, 3 ceiling fans, each of 80 watts. So we have fans, ceiling fans. So there are 3, and each one is 80. So that will give me 240 watts. Then it said air conditioner, an air conditioner. So they have an air conditioner rated 1,500 watts. Operated for 6 hours. So this was operated for 6 hours, and this was also operated for 6 hours each day. So 7 lamps, each rated 40 watts. So we have what? Lamps, and there are what? 7. Each of them is rated 40 watts. Moving on from there. So that will give me what? 280 watts. Are switched on for 10 hours. So these lamps are switched on for 10 hours each day. Then it said home theater, 100 watts. So we have home theater. Home theater is 100 watts. And then we have TV sets, 80 watts. And these ones are switched on 5 hours each day. So this is 5 hours. 5 hours. Then in standby mode, so they are keeping both this home theater and TV also in standby mode. The power consumption is 5% of the power rating. So we also have standby for home theater, 5%. We also have standby for TV, 5%. Moving on from there, the question said, calculate the total energy consumed in the house for 30 days. So we have to find the what? Total energy consumed in the house for what? 30 days. And before you can do that, we have to find out what the total for each one of them is for the hours that was spent. So here we have, for 6 hours, we have 240 times 6. So I have 240 times 6. And that will give me 1,440 watts. Then for the air conditioner, this is 15 times 6. That will give me 9,000 watts. And then this, I have 280 times 6, and that will give me times 10. because this was operated for 10 hours. That will give me 2,800 watts. And then I have the home theater that was operated for 5 hours. So this will give me 100 times 5, and that will give me 500 watts. Then I have my TV that was operated for 5 hours, and this is 80 times 5, and that will give me 400 watts. And then this TV or home theater was on standby and is at 5% of its original, and it was, so if this is 5 hours, it means that my standby is 19 hours, and this is also 19 hours. So it's on standby for 19 hours, but out of 24 hours, you have used what? You have used the TV and the home theater for 5 hours. It means for the remaining 19 hours, it will be on standby. So my 5% of the energy consumed, 5% of 100 watt there is going to give me 5 watts times my 19 hours. So I have 5 times 19. So that will give me 95 watts. So I also have standby for my TV. So 5% of 80 watts is going to give me 4 watts times 19. So I have 19 times 4, which will give me 76 watts. It means we have to find total energy consumed in the house for what? 30 days. So, and they say we should calculate it in kilowatt hour. So, all you have to do here, in order to convert this to kilowatt, you just divide by what? 1,000. So, this will give me 1 point. So, this is watt hour. This is watt hour. This is also watt hour. So, if you convert the kilowatt hour, I have 1.44 kilowatt hour by divided by kilo. This will give me 9 kilowatt hour. This will give me 2.8 kilowatt hour. This will give me 0.5 kilowatt hour. This will give me 0.4 kilowatt hour. This will give me 0.095 kilowatt hour. And this will give me 0.076 kilowatt hour. So, if we add everything together, we'll get our total energy consumed. So, my total energy consumed, total energy, is going to give me 1.44 plus 9 plus 2.8 plus 0.5 plus 0.4 plus 0.095 plus 0.076. So if I add all of these, I have 1.44 plus 9 plus 2.8 plus 0.5 plus 0.4 plus 0.095 plus 0.076. So that will give me a total of 14.311 kilowatt hour. So it means that the total energy consumed for 1 day. So this is total energy consumed for 1 day. So this is for 1 day. So for the 30 days, so if this is for 1 day, because what we have calculated here is just for a day. So if this is for 1 day, for 30 days, all we have to do is what? Multiply this times 30. So for 30 days, what I'll be having is 429.33 kilowatt hour. So for 30 days, we have what? 429.33 or 0.33 kilowatt hour for the what? 30 days. So this is the amount of energy that was what? Consumed in 30 days. But Roman figure 2 says we should find the total cost of operating all the appliance for what? 30 days at 10 kobo per kilowatt hour. So if we are to find the total amount that was used by this particular individual in his house for operating this appliance, since we know that he used a total of, so we know that the total energy there was, so we know that the cost is going to be the price times the total energy consumed. And the price here is 10 naira per kilowatt hour. So times my total number of kilowatt hour, which is 429.33. So it means that this person is going to be using 4,293 naira 30 kobo. So it means that at the end of 30 days, for what this particular individual has used, is going to be paying what? 4,293 naira 30 kobo if it is charged at what? 10 kobo, 10 naira per kilowatt hour. We know to the next question, which is question number 3. 3A says define. Remember figure 1, principal focus for a diverging lens. Now the principal focus for a diverging lens is the point on the principal axis where the rays of light seem to diverge after passing through the lens. So the point where the rays of light seem to diverge after passing through the lens of a diverging lens is called what? The principal focus of a diverging lens. Now, remember figure 2 says, what is the principal axis? Now, the principal axis is a line, a straight line that passes through the optical lens or the optical center of your lens and the center of curvature of the lens. What do I mean? If I have a lens, let's say I have a convex lens, for example, and this line that passes through the center of this convex lens here, the line that passes through the center of this convex lens here is called my principal axis. So it passes through the center of the curvature and what? The optical center of this particular lens, and it's called what? The principal axis. Remember figure. Okay, that takes us to question number 3B, which says state a situation under which the speed of light can change. Now, the speed of light can change only when it moves from one medium to another. So when there is a change of medium, then the speed of light can change. For example, if light starts traveling from air to glass, the speed of light in air is not the same thing as the speed of light in glass. Likewise, if it's traveling from glass to air, so the speed what? Varies. Likewise, if it's traveling from air to water, the speed also what? Varies depending on the medium. So the situation where what? Speed of light can change is when it what? Moves from one medium to another. Moving on to question number 3C. It says the separation between the lenses of an astronomical telescope in normal adjustment is 35.0 centimeters. So they've given us that the length or the separation is 35 centimeters. Then he said, and the angular magnification, our magnification was given as 8. Calculate the focal length of the lenses. So we are looking for the focal length of the lenses. So we do not know our F0 and we do not know our Fe. Focal length of the lenses. Then the next part of the question said the lenses separation are adjusted to produce the final image 30 centimeters from the eyepiece. So they have a new adjustment to produce the image 30 centimeters. So we have our final image at what? 30 centimeters from eyepiece. Moving on, we have calculate the new separation. So we are looking for the new separation we do not know of the lenses. Then sketch a ray diagram to illustrate the image formed in 3C. So all we have to do here is what? To first of all find what our F0 is and find out what our F is, and then we'll find our new separation to be able to solve the question. The first thing I will tell them, or I will do to solve this question, is to indicate that my M is equals to F0 over Fe. And in my M has been given in the question as 8, so I have 8 is equals to what? F0 over Fe. So this is the same as saying that my F naught is equals to 8FE. But I know also that my length is equal to F naught plus FE. So, and my length was given in the question as 35. This is equals to F naught plus FE. And in this question, I already was indicated or calculated that my F naught is equal to what? 8FE. So this is the same as I have 35 is equals to 8FE plus FE. This means I have 35 is equals to 9FE. If I divide both sides by 9, this means that my FE is equal to 35 divided by 9. That will give me 3.889. So if my FE is 3.889 and I know that my F naught is equal to 8FE, this means that my F naught is equal to 8 times 3.889. Or you can simply say that your F naught, either you say this, or you can simply say that since we know that my L is equal to F naught plus FE, and this is the same as saying that I have 35 is equal to F naught plus 3.889. So it means therefore that my F naught is going to give me 35 minus 3.889. It means that my F naught is going to give me 31.111 centimeters. So for us to be able to find our new separation, we know that from our final image that was given, which is same as saying what? The image distance that was given, VE, here is 30 centimeters. And because it is a divergent lens, it means what I'll be having here is minus 30 centimeters. So what we are going to do is tell them that what we are going to be using our length formula, which says what 1 over F is equals to 1 over V plus 1 over U. Since we're talking about what that of the eyepiece, let's just add E to all of it. So this is the same thing as saying that I have. This will give me my 1 over UE here is going to be equal to 1 over F minus 1 over VE. So, but because what we have here is negative, automatically what I'll be having is 1 over UE is equal to 1 over FE plus 1 over VE. Why? Because I'm talking about what? The diverging length. So this is the same as saying that I have my UE to be equals to FV over F plus V. So this is the same thing as saying I have. So my FE that we calculated was 3.889, and my V that was given in the question was 30. This is divided by my FE is 3.889 plus my V, which is what? 30. So this will give me 3.889 times 30. That will give me 116.67 divided by 33.889. This means that when I divide there, my object distance from the eyepiece is going to be 3.442 centimeters. But then that is not all, because the question is to find the what? The new separation. Our new separation is equals to my F naught plus my object distance. So this means that I'll be having my F naught was calculated our F naught as 31.111 plus 3.442. It means when I add these two together, 31.111 plus 3.442. It means that my new separation is going to be 34.553 centimeters. So this is equivalent to saying approximately 34.55 centimeters, or 34.6 centimeters. So that is question number 4, which says state the principle of conservation of energy. Now, the principle of conservation of energy simply states that energy can neither be destroyed nor created, but can be transformed from one form to another. Energy can neither be created nor destroyed, but can be transformed from one form to another. That is the principle of conservation of energy. Question number 4b says, state 3 effects of heat on a substance. Now, one of the effects of heat on a substance is change in temperature. That's the first effect. And that effect of heat on a substance is change of state. So there can be a rise in temperature. When you heat up a substance, there will be what? A rise in temperature. When you lower the heat of a substance, there will be what? A reduction in the temperature of the body. Likewise, when you heat up a substance, it changes state. For example, if I have ice and I heat it up, it will become what? Liquid. And if I continue heating, it will become what? Gaseous form of water, which is what? Steam. So another effect of the heat on a substance is change of state. And then the third effect on heat on a substance is expansion or expansivity. So there's what? An increase or a reduction in the size of the substance being heated. So that is also question number 4c, which says, explain why the bulb of thermometer is dipped into Explain why when the bulb of a thermometer is dipped into ice cold water, the mercury level first rises before falling. Now, when you dip the bulb of a thermometer inside ice cold water, the first thing that happens is that the bulb containing the mercury first contracts due to what? A reduction in its size. So it contracts, meaning that what? Because the temperature is lower, it is going to what? Reduce. It is going to shrink. So the bulb shrinks, and because the bulb shrinks, it forces the mercury inside the bulb to move upward. So the mercury moves upward as a result of what? The contraction of the bulb. Hence what? The mercury appears to rise. And after some time, we discover that what? Even the mercury absorbs some of or discover that what there's what a reduction in what heat. So the mercury is also going to lose some of its heat, and it's also going to contract, and it's going to what? Reduce. And then you can now read what? The thermometer to tell what? The reading or the temperature of that particular substance. Moving on to question number 4d. Question number 4d says water of volume 200 centimeter cube. So we are given the volume as 200 centimeter cube in an aluminum container at 20 degrees Celsius. So we have the temperature as 20 degrees Celsius. Is cooled to minus 10 degrees Celsius. So we have the final temperature, theta 2 here, as minus 10 degrees Celsius. They said when put in a freezer, calculate the quantity of heat extracted from the water. So we are trying to find the quantity of heat extracted from the water. So looking at this, now the first thing that you're going to discover here is that this particular water has passed through 3 different stages. Now we know that first you are going to what? Extract heat until it is what? 0 degrees. So from 20 degrees Celsius to 0 degrees Celsius, what I'm going to be having here is specific heat capacity. And then from within that 0 degrees Celsius, I'm going to be having specific latent heat. And then from 0 degrees Celsius down to minus 10 degrees Celsius, I'm going to be having specific heat capacity. It means here that I'm going to be having here the specific capacity of water, and here I'm going to be having specific capacity of ice. And at 0, I'm going to be having what? Specific latent heat. It means that my quantity of heat that will be extracted will be equal to MC change in theta plus ML plus MC change in theta. But here, the difference here is this. This is MC of water. Then my change in temperature here is going to be 20 minus 0 plus this is going to be mass and what latent heat of ice, plus here I'm still going to be having my mass, and then I'm having what specific capacity of ice, and then my change in temperature here is going to be moving from 0 degrees Celsius to minus 10 degrees Celsius. So for us to be able to solve this question, we have to know the mass of this particular water. And for us to get the mass, we have to use our pressure. And we know that the pressure of water is always 1000 kilogram per meter cube. So with this, we know that pressure is equal to mass over volume, which means that my mass is equal to pressure times volume. So with this, we know that we have 1000 times 200 over 100 0 0 0 0. And how do I get this value 1 million under? Because I have centi, and if I raise centi raised to power 3, which is centi is times 100. If I raise it to power 3, I'll be having 1 million. So if this 3 0 cancel 3 0, 2 0 cancel 2 0, I'll be left with 2 over 10, which will be 0.2 kilogram. So it means I have 0.2 kilogram as the mass of the water. So I have 0.2 times the specific capacity of water here is a constant. So H2O of water is 4,200 joules per kilogram per Kelvin. Joules per kilogram per Kelvin. And that of ice is 2,100 joules per kilogram per Kelvin. And then the specific latent heat of steam of ice here is 336,000 joules per kilogram. So with these values, I will then impute my values. So this will give me 4,200 times 20 plus 0.2 times 336,000 plus 0.2 times 2,100 times. So if I open this bracket, I'm going to have 10. So this means that I have 0.2 times 4,200 times 20. That will give me 16,800 plus 0.2 times 336,000. That will give me 67,200 plus 0.2 times 2,100 times 10. That will give me 4,200. So if I add everything together, I'll be having 88,200 joules. It means that the total quantity of energy that was extracted from this water is 82,200 joules of heat. So we've come to the end of today's class. I believe you had a wonderful time. Don't forget to go to the channel for more videos just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, GCE,